Welcome to Remainders and Divisibility. Today, we're going to tackle some exciting Math Olympiad problems together. But first, let's make sure we understand the basics. What is a remainder? Let's find out using cookies. Imagine you have 13 cookies. Now, let's try to share these 13 cookies equally among 4 friends. Each friend gets 3 cookies. That uses up 12 cookies. But look, there's 1 cookie left over. That leftover cookie is what we call the remainder. So 13 divided by 4 gives us 3, with a remainder of 1. The remainder is simply what's left after sharing equally. But what happens when the cookies divide perfectly? This time, we have 12 cookies for 4 friends. Each friend gets exactly 3 cookies, and nothing is left over. When the remainder is 0, we say the number is perfectly divisible. Now that we understand remainders, let's put our knowledge to the test. Here's our first challenge from the 2022 Raffles Math Olympiad. Read it carefully. If the 9-digit number 123 ABC 789 is divisible by 999, what is a plus B plus C? Let's look at the structure of this 9-digit number. Notice how it naturally splits into 3 groups of 3 digits, 123, ABC, and 789. Now here's a really neat trick. Look, 1000 is just 999 plus 1. So when we divide 1000 by 999, the remainder is just 1. Keep this in mind, it's our secret weapon. Let's break the number apart. 123 ABC 789 equals 123 times 1000 squared, plus ABC times 1000, plus 789. Now here's the clever part. When we're checking if something is divisible by 999, we only care about remainders. Since 1000 has a remainder of 1, we can swap every 1000 for just 1. Think of it this way. 1001 behave exactly the same when you divide by 999. So the remainder simplifies to just 123 plus ABC plus 789. For the number to be divisible by 999, this sum must equal 999. So 123 plus ABC plus 789 equals 999. That gives us 912 plus ABC equals 999, so ABC must be 087. Therefore, a plus B plus C equals 0 plus 8 plus 7, which gives us 15. Nicely done. Let's move on to our next problem. This one is from the 2017 Raffles Math Olympiad. John chooses 3 different numbers from 2017 to 2035. How many ways can he choose them so that the sum is divisible by 4? The first thing we need to do is sort these 19 numbers by their remainder when divided by 4. Look, the numbers naturally fall into 4 groups based on their remainders. We have 5 numbers with remainder 1, 5 with remainder 2, 5 with remainder 3, and only 4 with remainder 0. These counts will be important later. Now we need to find all the ways to pick 3 numbers whose remainders add up to a multiple of 4, that is, the remainders must sum to 0, or 4, or 8. Let's list all the valid remainder triples. Remainders 0, 0, 0 gives us 4 ways. Remainder 0, 1, 3 gives 4 times 5, which is 100 ways. Remainder 0, 2, 2 gives 40 ways. Remainders 1, 1, 2 gives 50 ways. And remainders 2, 3, 3 gives another 50 ways. Adding them all up, we get a total of 244 ways. Wonderful work. Alright, time for something different. Question 3 comes from the 2016 Raffles Math Olympiad and it involves factorials. Remember, n factorial means multiplying all whole numbers from 1 up to n. What is the remainder when we add up all the factorials from 1 factorial to 2016 factorial and divide by 15? Let's start by listing out the first few factorials. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and 6 factorial is 720. Now here's the key insight. Let's look at 5 factorial more carefully. 5 factorial equals 1 times 2 times 3 times 4 times 5. Watch what happens when we group these numbers cleverly. 2 times 4 gives us 8. And 3 times 5 gives us 15. So 5 factorial equals 8 times 15. That means 5 factorial contains 15 as a factor. It's divisible by 15. And since 6 factorial, 7 factorial, and every larger factorial all contain 5 factorial inside them, they must also be divisible by 15. This is brilliant news. It means in our big sum, only the first 4 terms, 1 factorial through 4 factorial, actually contribute to the remainder. Everything from 5 factorial onwards is divisible by 15 and gives remainder 0. So we just need 1 plus 2 plus 6 plus 24, which equals 33. And 33 divided by 15 gives us 2 remainder 3. The remainder is 3. Brilliant. Alright, one last challenge to go. This one is also from the 2016 Raffles Math Olympiad, and it's about powers and their last 2 digits. To find the last 2 digits, we just need to track what happens when we raise 7 to different powers. Look at the pattern. As we go higher and higher, the last 2 digits cycle through just 4 values, and then we land on 0, 1. Now here's the key insight. Once we reach 0, 1, the pattern must repeat. Why? Because multiplying 0, 1 by 7 takes us right back to 0, 7, exactly where we started. So this cycle loops forever. Now let's do the same for powers of 21. Again, we see a repeating cycle, and once we hit 0, 1, the pattern starts over. Now we just need to add every possible combination of last 2 digits from the 2 cycles, and see which sums we can make. Let's check each answer choice. Can we make 22? Yes. Can we make 24? Yes. Can we make 28? Yes. But can we make 20? Let's look carefully through the table. No. 20 never appears. So the answer is A. 20 could not be the last 2 digits of x. Let's recap what we've learned today. First, split big numbers into groups to check divisibility. Second, classify numbers by their remainders to count combinations. Third, large factorials become divisible, so only the small ones matter. And fourth, powers repeat their last digits in cycles. Keep practicing, and remember, maths is all about finding clever patterns. See you in the next video.